Hello everybody. Hello everybody. My name is Pawan Mishra and I will be the presenter for this webinar. Basically, what is the purpose of this webinar? The purpose of this webinar is to introduce everybody what are exactly the grid infrastructure, right? And how we can relate it with Oracle Network. Now, when we talk about this particular webinar, then what I am going to cover today is that are what is cluster, advantages of cluster, what is Clusterware exactly, what is this Clusterware 11gr2, what are the services provided by the cluster, and what are the different configuration files related to Clusterware, and what is new in this Clusterware Oracle 11gr2 Clusterware, and what are the Clusterware shared storage, what are the networking components used by this Clusterware, and what are the different Clusterware processes. And what is real application cluster, why we called it real application cluster, right? What is the meaning of real application cluster, and what are the hardware requirement required to install this Oracle RAC setup. And at last we will also cover, I will also cover what are the topics I am going to cover with this particular, if you attend my class and join this Multisoft, then what are the topics with this particular course content I will cover, right? So first thing is, what is cluster? If we talk about cluster, cluster is a group of independent but interconnected computers. Interconnected means they are connected, they communicate with each other through a high speed network, right? We will discuss it, right? And why I'm saying it independent means, these servers are not physically connected, right? But they are connected with each other through a private interconnect, and that private interconnect is a very high speed network, right? Now, clusterware means, a clusterware is a group of independent but interconnected computers whose combined resource can be applied to process a task, right? They are, suppose user is putting his request to that clusterware, right? So that cluster, so that user does not know that to whom I am going to submit it. That user just know I am going to submit that request to a cluster, and cluster is group of computers, right? But exactly what happens, that user knows this group of computers, and basically that request goes to that group of computers and allotted to a single computer in that particular group, means in that particular computer, right? If we talk about cluster, this is something like that we have assigned a task to a group of people, and they are completing that task by communicating with each other, right? To communicating with each other through private interconnect, they are able to communicate each other independently, in the sense that they are not physically connected. Now, these servers, means these individual servers, appears to an application as if it is a single server, right? As far as users are concerned, they will be connected to not a particular server, they connected to a group of servers, right? So that user will say, I am going to connect, I want to connect to a cluster, right? So now the task for this user is performing by takeover by a cluster, right? So we will see later, as a part of load balancing and other things, that user will connect to any one server within cluster, and how load balancing will take place, how high availability will provided by this cluster, right? Now, all these computers, they are going to carry out one task, so they need a shared storage, So user is working on same set of data. So they need a shared storage which is accessible by all these servers, right? Because these servers are able to access all the data. That's why that data should be put on a shared storage. So to talk among all means themselves, they need to private interconnect. So this is the private interconnect. They are connected to a private switch, and these private switch is connected to a storage, shared storage that also connected to a network, right? And all these clusters are connected to a public network that user can access at public network. So as far as Oracle cluster is concerned, it is mandatory all the nodes in a cluster must share the same processor architecture. What it means? Same processor architecture means if all the cluster has 32-bit operating system or 32-bit processor or 32-bit operating system, every node or every server in a cluster should have same processor architecture. Or if we have installed 32-bit OS on single server or 64-bit OS on a single server, so all servers in a cluster should have same operating system, right? Means if we talk about same physical architecture, they all should have same physical architecture. Even the network card should be same in all the cluster servers, right? So we cannot means if we talk about this, we cannot have no node or any one node is running on Windows or any other node is running on Linux. So should all should have same operating system and same processor architecture, right? So what are the advantages of cluster? First is scalability of application, right? Scalability of application means what? So we know that what is the cluster? Cluster is a set of computers which appears as a single unit of server to application and process that task that do the task together, right? So why we need a cluster? We could have process that task using one computer only. So what are the what are the advantages and what are the need of using cluster? So first is scalability. So what scalability means? It might be I have created an application, right? That only at present that have only 10 users are connecting to that particular application, right? As as of now, I have deployed only one server and server is sufficient able to satisfy the performance requirement of the user. But tomorrow, what happens as the domain of application increases, more number of users are going to connect now, right? So as the domain increases, number of users will also increase. So whatever the server, suppose you have taken a very high-end server, now the number of users is increased so much that that high-end server is not able to perform the specified task. Means you are not getting proper performance from that particular server. Your application is going down just because of your server, or going slow just because of your server. So, but if we have a cluster, suppose in spite of applying a high-end server for that particular application, we have deployed a small configuration of a bunch of computer in a form of a cluster. So we have a cluster. So what we can do, we can add node to that cluster. As the number of user increases, we can add node. So many number of increases means suppose number of increases 10 times, right? And after increasing the number of user, we added means on same amount of nodes to that particular cluster. Nodes means servers to that particular cluster, right? So why we are doing this? To get the same performance, right? So as per the requirement, all of them get the same performance, right? And we can increase the number of nodes. Means we can scale the performance of our application. So this is called scalability of the application. Means more number of user can connect with without affecting the performance of the. Now next is high availability. High availability is what? If I have only one node, one server to which I have to deploy my application, in case my that in case that server goes down or that server crash, my application will down. Okay, but in case I have deployed cluster and one server goes down, then the application is available on other server, right? Which is other server within that particular cluster, right? So this is the phenomena of high available, means every time your application is available to use. Next is load balancing. Load balancing is what? Since we have multiple servers doing the task collectively, then the workload will be shared, right? So distributed means the workload will be distributed among various servers within the cluster. So what happens? One node will not exhaust with a lot of load. So as the load is coming, the load is distributed among the least node in the cluster, right? So next is dynamic provisioning. Now dynamic provisioning is what? As per my workload, I can increase or decrease the number of nodes. I mean decreasing the node is not on the similar fashion that I am going to previously it was 3 node cluster. I have scratch out one node from the cluster. No, not in that sense. What I am saying, I can going to specify that this particular report will at present no work. So I have deployed only 2 nodes for that particular node. But on month end, I need more workload, means regarding that particular report. So I need workload to generate huge report. So we increase the number of servers for that particular node. So this is called dynamic provisioning. So dynamic provisioning means I can increase or decrease the number of nodes depending upon the workload for particular resource. Next is reduce cost of ownership. Suppose I did not have cluster and I have an application with varying workload. So we should have server capability to meet out the peak load requirement. Might be, suppose your peak load requirement might be there for only 10% of the whole time. That means my server on which I spent a lot, but I am able to use it 90%. I am not able to use it 90% of the time. That means that whole server on which I have spent a lot and that server is underutilized. And moreover, I do not have high availability as well. In case of server caches, my application is also down. But if we have a cluster, means in spite of having one huge computer, let us say small 5 computers, when my workload is high, I will deploy application on all of them. But when my workload is low, I will use only one or two computers within the cluster, right? And rest of the 2 or 3 can be used for some other task. So overall, my total cost of ownership will be decreased, and I am also getting high availability and load balancing, etc. Right? So what is clusterware? Clusterware means in a cluster, multiple computers working together as a single unit by communicating with themselves. It means there has to be some software who is making these coordination possible. This software is called Oracle Cluster. right? See, this Oracle Clusterware software reside on the top of regular operating system and provides various interface and services for a cluster. Okay, that means a clusterware is a basically certain processes, certain configuration files, and some algorithm. The combined resource of all of these is called Oracle Clusterware. That is basically controlling, managing the functionality of a cluster, right? If we talk about nodes, these nodes are dumb nodes, means these nodes are basically the dumb node, means they do not know anything. And when we implement Clusterware, they started to manage high availability, load balancing, node evacuation, right? All these things, right? This point is clear? Okay. Now, Oracle Clusterware. Prior to Oracle 10G, Oracle did not have their own Clusterware. If we want to install RAC database, we need to install third-party Clusterware. That is Sun Cluster, Veritas Cluster, HP265 Cluster, right? There are some number of Clusterware software was available that are certified for Oracle installation. In Oracle 10G R1, Oracle introduced its own Clusterware, and as a part of, right, Oracle Clusterware has been first introduced in Oracle 10G release 1. Now, Oracle Clusterware has shared this cluster architecture supporting application load balancing and failover, right? It is a shared disk cluster architecture. That means it has shared storage and supports application load balancing, failover. That means if one node crashes, then the application prior to connecting that node, that will go to failover to other node, whatever the specified node has been designated there, right? So when we talk about Clusterware with Oracle 11G R2, Oracle means when we also know that in Oracle 11G, in Oracle 10G, there is a new thing has been into that is called ASM, automatic storage management, right? That has integrated with Oracle grid infrastructure. What it's mean? Prior to 11G R2, what happens? The grid home and the ASM home both are installed in a separate home directory, right? But with Oracle Grid Infrastructure 11G R2, both homes has been combined in a single home directory, right? There is no need to install separately. Means automatically that will include automatic ASM and the clusterware. Both are installed in single home directory. It will also enable the ACFS, ASM cluster file system. So what happens prior to 11G R2 means prior to introducing this ACFS. What is this ACFS? Prior to introducing this ACFS, we can store our data files, redo log files, all these files into ASM. We cannot store movie, pictures, text file in ASM. But after coming this ACFS, ASM cluster file system, we are able to put inside ASM all our movies, all our pictures, all our text files, right? Now, a generalized cluster infrastructure for all kind of application tightly integrated with Oracle Real Application Cluster. What does it mean? Oracle Real Application Cluster. Now, cluster point is clear. Now, when we talk about Real Application Cluster, Real Application means when we manage a database using this cluster. That means you want high availability of my database, right? That means multiple computers are connected as a cluster, and whatever the database we deployed, that will be a resource for that cluster. Means that will be resource for this cluster. It means this cluster has implemented to manage the high availability and load balancing for this particular resource, and the resource is the database or any third party application or any other, right? Now when it could be a database, then it is called Oracle Real Application Cluster, right? So it is tightly integrated with Oracle Real Application Cluster. There can be only one installation of Oracle Clusterware running in a cluster, right? What it means, we will install one Oracle Clusterware installation in which we can put different databases. Means different database means Oracle database for different that can be a different versions. Means that can be a 10G, 11G, 9i, anything. But the clusterware will be the one for whole rack. Oracle clusterware is installed independently of Oracle database. This point is clear. The Oracle grid infrastructure home cannot be stored in shared file system. So what it means? When we talk about, there are two things. First of all, operating system has been installed. On top of operating system, grid infrastructure has been installed. On top of grid infrastructure, Oracle software will be installed. So there are two things. One is grid home, another is Oracle home. Both home will not be preferred to put on shared storage, right? Both home means both software should be installed on local. Suppose there are 3 nodes in your cluster or 3 servers in your cluster, then all 3 have their own independent home directory. Means every node should have, we should have to we must have to install grid infrastructure individually on 3 nodes. As we start on, means we install on one node, automatically as a part of grid infrastructure installation or Oracle software installation, the same home will be copied to all the individual nodes. Once Oracle Clusterware is installed, you can install Oracle database. The same I have explained. Same means that has installed on, means first of all, so Oracle software has been installed. Thereafter, database will be installed. Or Oracle RAC on the node in the cluster. The release of cluster must be equal. Means whatever the clusterware version you are going to use, that must be equal to or higher than the database you are going to install, right? So whatever the clusterware you are going to install, that must be, when I'm talking about RAC, what it means, real application cluster, means cluster which is managing the database. So what this point mean is, the clusterware should, the version of clusterware should be greater than or equal to the database, whatever the database you are going to install. So the last point is, there can be multiple Oracle homes for Oracle database, right? We can install multiple database. Means we can install different database or 10G, 11G, 9i, and both have different Oracle homes. We can also install a single instance inside a cluster setup, and we can also install Oracle RAC as well in a cluster. Next is cluster management. So cluster management is what? Cluster management means allows the cluster to manage a single entity. Means whatever the services has been provided by the cluster. First is cluster management, means allows the cluster to be managed as a single entity. Enable server to operate together as if they are one. So first service provided by the clusterware to, means take a to whatever the communication are taking place between all the clusterware nodes, that has to be managed by the clusterware software. Next is node monitoring. Node monitoring means that is, there is a pinging mechanism, right? Every node will ping to other node to get the aliveness of that particular node. That is called, means in every second, that is called network heartbeat. Every second, every node pings the other node to get the aliveness of that particular node, right? So perform heartbeat check. That means that is called network heartbeat. To perform network heartbeat check of the nodes to make sure that they are available and running properly, right? In case the one or the majority of nodes do not found that means that Clusterware is running by using network heartbeat, do not get a response from that particular node, then that Clusterware is responsible to manage the integrity of that cluster. Means suppose that cluster means that particular node is not a part of that cluster, that means other cluster nodes are not able to communicate with that particular cluster node. So suppose some user request is coming, maybe that request allotted to that particular node, right? So to maintain the cluster integrity, that node can be evicted or fencing or fence, right? To maintain the integrity of the cluster, right? So next is Clusterware resource. Clusterware resource. Just a minute, right? Next is Clusterware resource. So Clusterware resource means Clusterware resources are what? Database instance, database services, listeners, right? Or we can say non-database application. So all that are there, they are situated on their own location, and that location should be known to all the nodes across the cluster. So what are the dependencies between these resources are, all these are maintained by this Clusterware software. And Clusterware resource can be managed from any one of the nodes, right? Means you can start one cluster node from other by sitting on that other by passing command to other Clusterware node, right? So give me a sec, right? I just need to start my cluster. Give me a minute. Okay. So next is network management. Network management is what? Network management means provisioning and managing of VIPs, virtual IPs, right? Basically what happens when failover has been taken place. So how that failover has been taken place means exactly the physical IP will not fail over from one node to another node, right? On top of physical IP, we allocate virtual IP. We define virtual IP. And cluster where means whatever the request has been come to that cluster where that comes to that VIP. And if that VIP is unresponsive, right, then means suppose that cluster is joined, then with that physical IP will unresponsive, then that VIP request will fail over to another node's VIP. So provision and manage the VIP addresses that are associated with cluster nodes or application resources to provide a consistent network integrity, right? Consistent network integrity regardless of which nodes are available and which are not. Next is time synchronization, means automatically synchronize the timestamp of all the nodes in the cluster, right? Means all the nodes should be synchronized with each other, with, means in regards of time. Next is high availability. This clusterware monitors and restart any of the resources that are going down. The prime responsibility of this clusterware is to manage the resources. If that resource is not available, it automatically tries to restart that resource. Okay. The next thing is clusterware configuration files. So as I have told that the prime responsibility of clusterware is to maintain the registry of all the resources. Second thing is to see which node is available in the cluster, is to check the aliveness of that particular node. So how that happens, how that clusterware do that thing. So first thing is voting disk. Voting disk is what? Voting disk records each node membership. Means there is a mechanism of heartbeat, their disk heartbeat. So every node maintain its aliveness on a voting disk, and this voting disk and the next thing is Oracle Cluster Registry (OCR), both situated on shared location, right? So every node can see whether that particular node made its entry into voting disk or not. So that decides the aliveness of that particular. Also, second thing is OCR. OCR is to store and manage the information about the components that Oracle Clusterware controls. Means, as I have mentioned, that it maintains the registry of all the resources. So where the registry has been stored, that registries are stored in OCR, Oracle Cluster Registry, right? So means different resources. If we talk about resources, so resources are what? If we talk about Oracle RAC resources, that are database, listener, VIPs, and different services, and any other application you want to run on that particular cluster. So as I have mentioned, both OCR and voting list must be accessible by all the nodes. So it resides on shared storage. The next thing is, which is the new thing for this 11G R2. As I have mentioned that this voting disk and this OCR maintains the shared information, means that information which is shared among all, right? But there should be some information that are local to that particular node, that are need to start that particular node. That information is maintained in OLR, Oracle Local Registry. And this two things, OLR and GPnP profile, both are new to this 11G R2. Prior to 11G R2, these two are not available. So the OLR is a local registry for that particular node, specific resources. That resources are local for that particular node, and that's why it is located on each node in the cluster. So instead of as I have mentioned, OCR is situated on shared storage. This OLR is situated on, right, because it contains the information that is specific to particular node. Now, next thing, GPnP profile. When we talk about GPnP profile is a very small XML file. Basically, that is used to establish the correct global personality of the node. What it means? Suppose if we talk about, means what Clusterware exactly knows, means what are the information required to start the Clusterware or Oracle RAC. First thing is SP file, ASM disk string, right? All these information must be stored on, means the location of that, all these things are situated in GPnP profile. Now, if I want to add something, means suppose I want to add add another node to that particular cluster, prior to 11G R2, we have to do lots of manual operations, right? But after introducing this GPnP profile, I just have to run add node.s, right? And all the required information has been gathered from this GPnP, right? So GPnP profile contains all shared information that are common to all the nodes. Okay, so next thing is Oracle Clusterware shared storage, option for shared storage for OCR and voting disk. that can be cluster file system, right? Oracle cluster file system or network file system. But Oracle always recommended ASM. So your shared storage should be on ASM starting with 11G R2. Prior to 11G R2, this is very frequently used in 10G that are raw devices. But starting with 11G R2, that raw devices have been deprecated. Now this is the Oracle Clusterware Networking thing. You can see there are two nodes, right? There are three nodes basically. They all are connected through private interconnect. They can communicate with private interconnect, and they can also communicate with user using public interconnect. So all nodes should require minimum 2 NIC cards. One is for public network and another one is for private network. So each node must have at least two network adapter or network interface card, one of the public network interface and one for private network interface, and both interface names associated with network adapter for each network should be same. Means suppose I have assigned ETH0 for public network in one node, the same should be on node 2 and same should be on node 3. If I have assigned ETH1 for private interconnect in one first node, then same should be on second and same should be on third. So for private network interface, we must have a user datagram protocol. For high speed network adapter switch, right, must be minimum of 1 gigabyte Ethernet. Crossover cables are not supported for Oracle this installation for cluster interconnect. So all should be connected through a switch or through you must have to connect it to a patch cord, right? Just a minute, give me a sec. My throat is becoming dry. Okay. The next thing is, you can see when we talk about public and private network, both should be on different IP range. Here you can see I have defined 192.168.1.75 for public network, but for range for private network is 10.0.0. something, right? Suppose you have three nodes, then 10.0.0.123 anything, right? So configure the private network on a separate dedicated network switch. So the private network is used for communication among the cluster nodes only in public connection. For example, from application user client program, do not use this network interface, right? Okay. Next is VIP, virtual IP. This is a small example of my TNS page, right? This is a small example of my TNS page. You can see, in spite of putting physical IP, I have given here VIP. So your request come to that particular VIP, which as defined on top of your physical IP. Suppose one is down, then that request will be fail over to second one, right? Second available IP, whatever the IP is defined. So client uses basically virtual IP address to connect the Oracle RAC database instance. So this VIP address is a static IP address for a specific server node in the cluster that resolves to a host name through the host file or domain name system DNS, and the new thing is GNS, right? So basically what are used to for these naming for these VIPs name resolution, we can use DNS or GNS. We will discuss in the meanwhile, right? So next thing is, as you know, this is the thing when I'm using different VIPs. So we need to mention three addresses there. Now what happens? We don't know, means suppose, right? What happens here? Suppose why I'm going to define this VIP. Suppose I have given this IP address here, means physical IP address here, and any request come to that particular system, right? But any request come to that particular node, then that request will wait for that particular node to be alive to up to the time of network time. Suppose you have given 10 minutes for network timeout, so that has to be maintained, means that has to be wait for 10 minutes to fail over to another. So the VIP address, what is the purpose of this VIP address? The VIP address resolves all the timeout entering to the TCP IP stack, right? And provide the high application availability, right? So when we define this VIP must be configured on unused or any resolvable IP address, right? Now, suppose you want to modify some, means suppose means you want to modify some, you need to modify this VIP as well. Now, what client know? Here you can see, here I have provided 3 VIP. In spite of giving 3 VIP, I have just given one name here. This is what? This is scan name. So there is a new thing has been introduced prior to 11G, means prior to 11G R2, the network configuration file on the client computer needs to be modified whenever whenever we nodes are added or to be removed. Means we have to go each and every computer and need to modify. Suppose I have added another node, I need to put a entry in each the node, all the nodes. Or suppose if I have removed some node, I have to remove that entry from DNS name from all the nodes, right? So in 11G R2, there is a new concept introduced that is called scan name, which provides a single name for client to access any Oracle database running on a cluster is irrespective of the number of servers. Means when user is connecting, users do not know from which I am going to connect. That user will connect to this particular scan name. This is a single host name for cluster, right? Now, by introducing this scan name, the client connection information do not need to change if you are going to add any node or you are going to remove any node, right? So this is the basic purpose of putting scan name there. Need not to modify TNS names entry from different nodes, means from all the nodes in case of adding or removing the node. You can resolve the name by using two methods. One is DNS, another one is GNS, grid naming services, or DNS, domain name services. So in case of domain name service scan, we provide one scan name and that scan name resolves 3 IPs, right? This is the default one. So whenever I'm going to define a scan name, that will resolve 3 IPs. And whenever user is going to connect to cluster, means going to Oracle RAC, connect to Oracle RAC, that can connect to any one of the IP address, right? Which has resolved by this DNS. So 3 static IP address should be configured on the DNS before installation so that these 3 IP address are associated with the name provided as scan. See, here you can see cluster 01 scan, the same I have provided here, cluster 01 scan and cluster 01.add. This is my domain name, right? So 3 IP address are recommended to considering load balancing, high availability requirement. Basically, this is the default thing. Means whenever we are going to use DNS, we must have to define 3 IP address to resolve the single, right? And all these 3 IP address must be same on the same subnet, and that subnet should be the same as your public network. Okay, all these three addresses are written in random order by the DNS to the requester. This is the networking part, right? So whenever user is going to connect to that particular Oracle RAC environment, any one of the means that user can connect to any one of the node where that scan are running, right? Basically, when I have defined three scan IP addresses. These three IP addresses will physically run on any three nodes of the cluster. Suppose there are four nodes, so and out of four nodes, three contains the three different IPs. Means these three IP addresses will run on three different nodes. In case of you have two node cluster, then any one can contain two and other one can contain one IP. So whenever user requests, that request goes to any one of the node where that scan is running. This is called, there are two types of load balancing. One is client side load balancing, another is server side load balancing. We will discuss it, right? This is part of client side load balancing. Now, for each, when we talk about these scan IPs, each scan IP contains three scan listeners. Means three IPs are basically the scan VIPs. These are virtual names, name resolved by the DNS. These are virtual IPs, scan VIPs, and each scan VIP resource will contain scan listener. That means if three scan VIPs are running on three nodes, so all these three nodes will contain three scan lists, right? So the fourth point is each scan VIP is associated with scan list. Three scan VIP will be dispersed across the cluster. Means these are three suppose there are three nodes. All three will run each and individual nodes. If there are four nodes, any three can contain these three scan VIPs. In case of cluster, three or more nodes, each pair of resource will be started on different servers of cluster. Pair of resource means scan VIP is one resource and scan listener is other resource. Both are allocated to three different nodes. In case of two node cluster, one server will contain two set of scan resources, means scan listener, scan VIP, other will contain one. If the node one which a scan VIP is running fails, then the scan VIP and its associated listener will fail over to next available node in the cluster, right? So if a node becomes available in a cluster, again the formerly mentioned dispersion will take effect and liquidate on the set accordingly. Means whatever the configuration was previously, that has been take place again. Okay, so now there are two things. One is local listener. This is my TNS names entry, right? This is my TNS names entry. There are two things. One is local listener. Another one is remote listener. Local listener will specify you the local listener which is running on that particular node, and remote listener will specify you the scan listener where exactly the scan listener is running. Now, see, this is the entry, right? This entry is cluster01 scan cluster01.example.com, and it is running on port number 1521. Now, whatever the name I will provide in this remote listener parameter in our TNS names, the pmon process of that particular node will register the load information of that node to that particular scan listener. And as I have mentioned, by default, I have defined three scan names, three scan VIPs. So there will be three scan listeners are running. So all three scan listeners contain the information of all the nodes load, means the load of all the nodes, right? So this is called client side load balance. I'm repeating again. The pmon process of that particular node register the load information to that particular scan listener, whatever the name has been provided here. And because these are running on three nodes, right? because 3 scan VIPs are running there and 3 scan listeners are running there. The same thing is running on 3 nodes. So all these 3 nodes contain the load information of all the nodes of that particular cluster, right? This is called client-side load balancing. So this allows the instance to register with scan listener as remote listener to provide information on what services are being provided by the instance and current load on the. Okay. So this is the connection load balancing using scan. So what happens? These are the application. This is the application server, and these are the client. These are the servers. And as you know, as I have mentioned that 3 scan listeners are running. Just because of client load balancing, and user will connect to any one of the nodes, right? And that node means these scan listeners are basically running on any 3 of the nodes of that particular cluster, Oracle RAC database cluster, any 3 of the RAC database cluster. So that information will be transferred to any one of the nodes, right? This is called client-side load balancing. Now, what happens? Because this scan listener knows that which node has least load in this particular cluster environment. So as this contains, as this particular scan listener receives the request of that particular client, and because that particular node scan listener know that which node has least load, by using the local listener, that request has been transferred to that particular node which has least node. This is called server side load. I am repeating. One of the node contains one of the scan listener of that any one of the node contains that request, and just because of client side load balance, that scan listener contains the information which node in this cluster has least node, right? Least load. So that request, by using the local listener, that request has been transferred to that particular node which has least node. This is called server side load balance. Next thing is scan using DNS. Now, what happens? Suppose you are going to add another cluster, another node. What you need to do? You just have to maintain that information in DNS as well, and that DNS has been managed by the network guys. So you need to contact to that network guys, right? And all the information, all the VIPs has to be maintained by the network guys, because Oracle is automating everything. Oracle do not want any Oracle do not means recommend to interference in the network or in the cluster environment by any other domain, by other guys, means that guys can be network or host level, right? So they Oracle introduced another concept that is called GNS. GNS is basically something like DSCP, as automatic VIPs has been configured to that cluster. So by activating GNS in a cluster required a DSCP services on the public network, means DSCP to be configured. As DNS will be configured, as GNS will be configured, automatically that whatever the node you are going to add, that will define a particular IP, and you need not to go to network guy and tell him to maintain entry for that particular node to the DNS entry. So Oracle Clusterware dynamically obtain the node VIP and 3 scan VIPs from the DHCP server, update the Clusterware resources, and make the server accessible through DNS. So means it automated all the things without interference of network people. So client resolve all the VIPs and scan addresses using Oracle Grid naming services, right? So how we maintain this GNS entry? As that entry should be maintained in name.conf. right? This is network related file, and you can see I have given this cluster name, thereafter the gns.example.com. This is the name, GNS name, and I have provided a static IP for that particular GNS entry, and only this static IP will run on a single node, right? I'm going to explain that in few of the slides. We will discuss it, right? So the cluster domain is defined as a delegate domain. The GNS VIP, the only static VIP required for cluster in GNS virtual IP address. GNS VIP should be defined in DNS domain. GNS and GNS VIP run on one node on the cluster, right? This is only the static IP that has to be defined, in spite of defining 3 DNS names or anything, or means any entry for that particular scan or scan VIP, right? This only has to be defined. If the server on which GNS is running fails, then the Oracle Clusterware fails GNS over to along with GNS VIP to another node of the cluster, right? So this is the architecture, means this is the GPnP profile architecture. Here you are able to understand what GNS is basically doing. Before of going that, I want to explain this slide as well. So whenever we set up a GNS, a daemon that is called MDNS, multicast DNS, multicast domain name service daemon, will run on all the nodes of that particular cluster, right? So within which resolve which accept the request, means which accept the request and provide that information to GNS to DNS, and DNS provide that information to client, and as receive the information of scan of that particular client, means that client receive the scan name, automatically that request goes to that particular node where that scans are running. So this is the architecture. What happens in case of GNS? As we know, means when I have defined this DNS, 3 scan listeners are running, or 3 scan listener will run. So in case of GNS, DNS, when client requests anything, that request goes to GNS, and this GNS transfer that request to a particular node where GNS VIP and GNS scan is running, right? That node, that particular node, multicast that request to all the nodes, right? That request will be populated inside the cluster. Because I have implemented GNS, this MDNS service is running in all the nodes. That MDNS service will receive that request, right? Also, that request has been received on the nodes where 3 scan listeners are running. So in response of that multicast, this GNS will come to know where these 3 scan listeners are basically running on which node. Suppose these are running node 1, node 3 and node 4, right? That information has been transferred to GNS, and GNS transferred to DNS, and DNS transferred to client. So now after that, the same thing happens. That request will transfer to any one of the scan listener, right? Suppose that scan listener is running here. Okay, so that scan listener knows the load information of that particular cluster nodes. So that scan listener transfer that request to least noded node through local listener, right? So this is the thing happens in case of you have implemented GNS. So an MDNS server is configured on each host. In case of GNS, when you will configure GNS, automatically a service that is called MDNS daemon will automatically configured in all the hosts. So DNS forward all the requests to the cluster. GNS daemon on the GNS virtual IP, where this is basically a single static of IP which is running on single node, will be receive that request and populate it and that request will go to on the node where scan listeners are running. That information has been gathered by the GNS and transferred to DNS again, and DNS transfer that request to client. Client transfer automatically that request to go to the node where that scan listener is running, and that is scan listener will transfer the request onto least loaded node through local listener. Okay, so GPnP profile, as I have mentioned that in previous release, adding or removing server in a cluster required extensive manual operation, right? But in 11G-R2, this GPnP profile has been introduced, right? So when we are going to do this adding or removing type of activities, that GPnP profile has been used, and all the shared information, all the basic information has been gathered from this GPnP profile, right? This GPnP profile has been saved on the location read home GPnP hostname profile peer under inside this peer folder there is a profile.x. It is used to establish the correct global personality of the node. Each node maintain a local copy of GPnP profile. GPnP profile is used to necessary information required for startup of Oracle Clusterware like SP file or ASM disk system. GPnP profile is maintained by GPnP daemon. This is a daemon. Change made to cluster and therefore the profile are replicated by the GPnP daemon, right, during installation, system boot, or whenever you are going to update your cluster. These updates can be triggered by making change with, there are some type of tools like OIFCFG, CRCTL, ASMCA, and so on, SRVCTL. This is a copy of GPnP profile. Here you can see, you can see ASM profile ID, ASM disk string, the SP file, path which is stored in ASM, right? Everything has been maintained. This is a file which is semi-structured, and this is an XML file. Now, in case of scan with GNS, every node should have at least one public IP, right? One public VIP, 3 scan VIP, and 1 GNS VIP, and a private interface, 1 node IP. Now, this is the Oracle Clusterware initialization process, right? The operating system init daemon will initiate Oracle High Availability Service daemon. That is exactly the situated in a script in a /etc init.d init.ohsd, right? That process initiate different types of processes, right? That are clusterware processes. And before means whenever we install this clusterware, a respawn option has been put inside this /etc init tab. Whenever we feel any problem in clusterware installation, first of all, this is the thing we first check, that whether the respawn option has been activated or not. This is by default activated, and this entry automatically takes place in init tab whenever we install Oracle Clusterware, right? So these are the clusterware processes. These are the different clusterware processes. So as I have mentioned that there are, first of all, Oracle init process that initiate that start the OSD process. In response of OSD process, in level 1 there are 4 processes has been introduced. We will discuss it in detail. Today is not the sufficient time to discuss all these processes in detail. So we will discuss all these things in detail. So first of all, when OSD started, then CST agent, which is basically the basic thing which is required, it maintains the voting list entries, and on top of that, thereafter OSD Aura root agent, Aura agent will start. Thereafter CSD monitor will start. OSD Aura agent will start 5 processes. That means 5 things, that is ASM and MDSD daemon, GIP CD daemon, EVMD event management daemon, and GPnP daemon. OSD Aura agent will start again 6 processes that are CRSD, CTSD, cluster time synchronization service daemon, cluster synchronization daemon, and O-logger service, Sysmon, and ACFS driver. And on level 2, there is another process that is Aura agent will start, that is CSD process. This is which is basically responsible to maintain the voting list entries. In absence of CSD, Aura CSD agent will take place, the responsibility of CSSD. CRSD process again in level 3 divided in two parts. One is CRSD Aura agent and is Aura root agent and CRSD Aura agent. CRSD Aura agent will again start the resources on level 4 that are related to network, node VIP, scan VIP, GNS VIP, ACFS registry. And CRSD Aura agent will start DB instance, database services, node listener, scan listener, ASM instance, disk group, ONS and GNS, right? So ASM is basically used, ASM is introduced in 10G, and which is the volume manager and a file system, and which is basically used for storage purpose. Oracle always recommend that you should have to use ASM only, right? ASM is automatically installed as a part of grid infrastructure on top of operating system. You need to install it separately, which replace the local volume manager which need to install prior to ASM, right? So ASM and grid infrastructure provide enterprise class shared storage. Everything is same. OCR we have already discussed all these. OCR and voting can be stored on Oracle ASM, right? Storing OCR and voting this on Oracle ASM eliminates the need of third-party Clusterware volume manager. Only one Oracle ASM instance is supported on server as a part of, because it is installed as a part of grid infrastructure. As I have mentioned, only one in grid infrastructure can be possible, right? But if I am going to install Oracle RAC, only one grid infrastructure will be installed, and because ASM is installed as part of grid infrastructure, so only one Oracle ASM instance is supported on Oracle server on a server. When managing ASM instance, the administration activity must be performed in grid infrastructure home, right? So what are the requirements to install 11G R2 RAC? Minimum 100 GB of because I am going to install all these things on virtual machine, so at least 100 GB of hard disk should required. At least 8 GB RAM to install one storage, DNS, and 2 nodes cluster, right? At least 8 GB RAM required. Operating system 5.7 or above, and the base operating system is on which I am going to we will install the VMware, that should be Windows 7 or above of that, and we need Oracle Grid Infrastructure software which I will provide you, and the Oracle 11G R2 software, right? So thank you very much for attending this webinar.